Good morning, Ma'am Kai. Good morning, classmates. Our assigned project for today is creating a planet. Now, the planet that we created today is a nitrogen-based planet. What do you mean by a nitrogen-based planet? We are exploring what a planet would look like if it used nitrogen instead of oxygen as the main component of life. Now, the question is, could it sustain life? Yes, but not human life. Nitrogen itself is not toxic, but humans need oxygen to breathe. With little oxygen, Earth-like animals couldn't survive. However, microbes, alien animals, and plants could evolve. Life would probably have slower metabolism, cold tolerance, and possibly using ammonia or methane instead of water.
Could plants exist? Of course, yes, but not the usual green plants. Instead of photosynthesis with oxygen, they might be called as alien plants. They use nitrogen and sunlight for energy, or use chemical energy like deep sea bacteria. The colors might be for the plants would be purple, black, red, and blue, depending on what light they absorb. They might release ammonia, methane, or nitrogen compounds instead of oxygen. And you may ask, would it have oceans and water? It depends on the temperature. If warm Earth-like, yes, could still have water oceans, but atmosphere is mostly nitrogen. If cold, it's more realistic to implement it. So ocean will have liquid nitrogen, liquid methane, and liquid ammonia. Water would be ice rock instead of liquid. What do you mean by that? The rock would be like ice, but instead of a fragile ice that you can easily break it with your own hands or bare hands or tools, it has the same durability of a rock. So that's why you call it an ice rock instead of liquid.
Could it have seasons? Yes, if it has a tilted axis like Earth, an orbit around a star. Seasons could be hot versus freezing nitrogen rains, thick fog seasons, and long dark winters with frozen oceans. Would the sun and moon affect it? Absolutely. Sun controls temperature, weather, storms, and most likely seasonal cycles. Moon affects tides if it has oceans, stability of rotation, possibly biological rhythms like Earth's tides. A big moon equals strong tides in nitrogen seas.
How different would it look from Earth? A nitrogen planet might look like. It may have orange or pale blue sky, thick fog everywhere, black or purple vegetation, low visibility, slow moving life, lightning storms in nitrogen clouds, and it may also have cryogenic rain in liquid nitrogen. A real-life example could be Titan, a moon of Saturn, is basically a real-life nitrogen world. It consists of 98% nitrogen atmosphere, lakes of liquid methane, no oxygen, and organic chemistry everywhere. So, for a summary, we have a summary table prepared. First, it has a feature column and a nitrogen planet column. Atmosphere, mostly nitrogen. Human survivable, X, no. Alien life, correct, yes. Plants, yes, but not green. Oceans, possibly water, methane, or nitrogen. Seasons, yes. Sun and moon effect, yes. Earth-like, X, very alien. Now that we've delved into how a nitrogen-based planet could look like, now we'll delve into the ecosystem of this planet. Now, an ecosystem consists of animals, so what environment does my animals live in? Nitrogen-rich air, almost no oxygen, cold climate, oceans of methane slash ammonia slash nitrogen, and it has dim sunlight because it's far from its star. This means that animals must deal with low energy, cold temperatures, no oxygen breathing, and a thick atmosphere. So, life is slow, efficient, built for extreme chemistry. How would they breathe? They don't use lungs like us, but the possible systems are A. ammonia respiration, instead of oxygen, they use ammonia or nitrogen compounds, similar to how some bacteria breathe sulfur on Earth. B. Chemical gills. Even land animals might have external gills, porous skin, and internal chemical reactors instead of lungs. What do they eat? No grass, no meat like Earth. Their foods are nitrogen plants, chemical mats, methane bacteria, and obviously each other. So the food chain looks like chemical plants to grazers to predators. Now for a side note, grazers are known as this planet's herbivores. So now we've taken the liberty to design what animals could possibly look like in this nitrogen-based planet with the help of ChatGPT. The first being glider herds or atmospheric filter feeders. Role in ecosystem. Primary consumers like cows plus plankton. Size from dog size to bus sized. Body flat manta ray shaped body, huge wing membranes, no flapping. They glide on dense nitrogen air. The anatomy is along the wings, filter pores that trap airborne microbes. Internal spiral chemical stomach. No eyes, only light sensitive patches. Movement. It rides thermal currents and it migrates around the planet in massive herds.
And we also have board crawlers, also known as the surface detritivores. Their role is clean up dead organisms. Their size is like a human size, reaching about I think 5'6" to 6 feet. And their body is described as 6 thick limbs low to the ground and body shaped like a peeled bug. And their skin is made up of rubber like outer layer resistance to cold and chemicals. And what they look like is on their face has no face at all, a ring-shaped mouth underneath body, and a chemical sensors instead of eyes. Their movement is very slow because they are burrow under frozen terrain. Why realistic? It's similar to Earth. Worms, beetles, or cucumbers, or flies. They have the similarities of eating dead organisms. Next, we got methane grazers or ocean herbivores. Their role is eat chemical algae in methane seas. Their size is like whale size. Their body is long torpedo shaped, 4 paddle fins, and thick fat like insulation layer. Their breathing absorbs dissolved gases through skin, and they have no lungs. And the way they feed themselves is they open their mouth, they filter the liquid, close, and digest, as if it's like a vacuum with a filter on. But why is it realistic? It's directly based on whales and the way they feed themselves through filter.
Poles, hunters, or predators. Rule, top predators. Size, wolf size. Body, thin spider-like legs, small central body, long tail. Senses, emit chemical pulses, detect reflections like sonar but chemical. Attack method, overload preys nervous chemistry, paralyze then absorb nutrients. Why realistic? Similar to spiders, octopus, electric eels. Spore walkers, walking ecosystems. Rule, mobile forest. Size, elephant size. Body, tall pillar body, dozens of stalks going from back. Each stalk produces spores. Function, animals live inside them. Spread microorganisms everywhere they go. Very slow. One step every few minutes. Why realistic? Like coral, fungi, giant sloths.
And that concludes our presentation. All in all, this topic is a wide and huge area to uncover. And with just our presentation, we wouldn't be able to explore and explain everything to you. So, I encourage you to do your own self study on what a nitrogen based planet could look like. Thank you for listening. And by the way, these are our members. Meet our team. This is Kyle Christian R. Kakanog. And the second picture is Nino Marcos Tusi. And we have Bryce Inghog with a special team member, Brad Pitt. So, that is all. Stay awesome and God bless. Adio et spero.